This is a quick overview of the course material for this semester's route surveying class. And formerly, this course used to be called construction surveying. It was renumbered, renamed as part of the state course reorganization about 4 or 5 years ago. But I still like to keep a kind of a heavy construction emphasis in this course because I think the principles of construction layout, radial layout, offset layout, calculating cuts and fills, earthwork quantities. I think that's still a really important component of the curriculum, and this is still a relevant course to include that information. So really, construction surveying can be summed up in two words. It's line and it's grade. Line is simply where does something belong, whether that feature you're working on is the edge of a sidewalk, like this case we were replacing a brand new sidewalk, so we were establishing an offset line to use as a reference for the construction crew. And grade is simply how high up or how high down are you building something. You know, you're familiar with this from last semester's surveying course. Line was simply kind of an expression of a northing and an easting position of a coordinate. And the grade is the z coordinate, the elevation. So we're going to use the same tools that we learned last year. We're going to use a total station and we're going to use an auto level. We will get into a little different application of those tools where we're going to interface with electronic data collectors to do some of the calculations for us. You know, you showed me last semester, you know how to do the calculations. So now we're going to let the field computers do that. And we're going to spend more of our time learning on how really to get that point in the ground where it belongs. Whether we're representing that point with a stake or a hub and attack, regardless of what feature we're putting in the ground, we need to get that thing within a hundredth of a foot, and our tools will help us do that, and we don't need to waste our time and energy working on calculations when computers can do that for us. So our role as construction surveyors is to convey that information then, the line and the grade, the northing, easting elevation, clearly and completely to a contractor. And we're going to talk about different means of construction communication. This is one example here. This is the most common example. It's a lath with some code written on that lath. And when you follow standard protocols, standard formats, that code is easily understood by a contractor because we're all speaking kind of the same language. Right here, this construction lath tells me that the feature being staked is a curb and gutter. It's a top back of curb. It's a 3-foot offset, and the grade from the construction stake is a fill 0.16 feet. And what that would look like in application is a hub in the ground, probably down here at the bottom of this offset stake, and the location of that hub is where these dimensions are being referenced from. So we're going to go through about 7 or 8 major topics in this course, and I just wanted to kind of highlight those to kind of prepare you for where we're going this semester. We're going to review kind of really quickly horizontal and vertical control. This is what we spent all semester on last spring with the Intro to Surveying class. In order to work on a construction site, you have to establish control around that job site. So you know how to do that now, and we're going to do that very quickly in the first 2 weeks of this semester. After we have our control established, we're going to branch off into construction staking and layout. We'll learn a couple different methods. Primarily, the most common method is radial stakeout, where we're going to execute radial measurements with the total station, so angle and distance, from a control point to establish design locations in the ground, such as here, here, and here. Those design locations might reference corners of a building, edges of a sidewalk, center lines of a road. We're going to work with all of those things this semester. Slope staking is really the heart of route surveying, because a route, like this center line of a roadway here, or this is up in Thompson Park, Eagle Nest area, center line of a roadway, that route has to be designed to fit into an existing terrain. So you have a flat road surface, probably some sort of drainage feature, like a ditch alongside that road, and then you have a safety slope or a cut slope tying your design feature back into the natural grade. And where that designed element, right, your cut slope, meets the natural grade, we call that a catch point or a slope staking point. And we're going to go through the process of learning how to perform slope staking in the field. Earthwork quantities, probably the most critical calculation you're going to perform with respect to construction surveying if you are an office worker, if you are an estimator, if you're a quality control person. A contractor needs to know how much material they need to move, and after they've moved it, they need to get paid, and payments can be a make or break issue for a small contractor, for a small office. If there's a little bit of an error on the elevation of that platform, on the slope used for these sides, it can dramatically affect the quantities of earthwork being calculated, and payments are important. People don't survive without making a profit, and you can't make a profit if you don't know accurate takeoff quantities. So we're going to learn how to calculate quantities. Road centerline stakeout. Couple of different ways to do this. We're probably going to establish in the field some just straight centerline roadways so that we can then perform kind of a little more advanced application of route surveying, horizontal curves. And a horizontal curve, as it implies, it's a portion of a circle, an arc, if you will, from a bird's eye perspective, that connects two linear tangent lines to one another. And you can see in this case we have points here, here, here. These are all points along an arc that are transitioning one straight line tangent to another straight line tangent. And you're familiar with this every time you drive down a road. When you go from one alignment to another and you have to spin that steering wheel to transition between those alignments, you're going along a horizontal curve. And we're going to learn how to calculate positions along a horizontal curve based on the radius of that curve, the length of that curve, and the degree of curvature, or what's the angle formed between this point of the curve, its radius point, and that point of the curve. Vertical curves. You also drive through these every day. When you come down a hill, you have to transition through some kind of smooth design feature before you can start ascending up the next hill. So we've taken that bird's eye perspective of a horizontal curve, flipped it on its side, and now we're looking at a cross-section perspective for a vertical curve. And these aren't really curves, these are parabolas. And you're familiar with a parabola from math class, but that parabolic feature of these curves help us transition more smoothly, and they don't jar, or they don't launch the car, so to speak, into an unsafe trajectory. And we're going to finish out this semester talking about another kind of linear route, and that's utility lines, primarily sewer service line calculations. We'll probably maybe do a little bit of water line measurements this semester as well, but sewer line So are much more critical because they require calculations because they're gravity dependent unless they're connected or serviced by a pump station or lift station. 99% of the sewer service lines out there are gravity fed. And gravity only works if you've calculated your grades correctly. So that's why we're going to spend more time working on sewer. That's an overview of this semester. I want to keep things fairly light this week. I just want to have you do a little bit of reading in the chapter, get you in kind of back in the mode of thinking about the role of surveying as it relates to our job as construction inspectors and field engineers.